Hey guys, how's it going? This is Sid and welcome to another LeetCode programming video tutorial. Today we are going to solve problem 79, the word search. And this is also one of the top most asked questions in Amazon interview. So the question stem says, given a 2D board and a word, find if the word exists in a grid. The word can be constructed from letters of sequentially adjacent cell, where adjacent cells are those horizontally or vertically neighboring. The same cell may not be used more than once. So what they have over here is they have a grid and they are giving us a word and we just want to find it, whether it exists in the grid or not. So for example, the word A, B, C, C, E, D exists because all the characters in the word can be found by either moving in horizontal or vertical direction. However, the A, B, C, B, so A, B, C, and B is incorrect because we are reusing the same character twice. So we are not allowed to do that. So how can we solve this? If you already haven't figured it out, then we are going to use PFS. And we have already solved one problem in a similar fashion. It was called number of islands. Have the links in the, if you have been following my series, then you would have already known, but otherwise the links in the description below, so do check it out. Now let me walk you through an example of how the PFS would work and how the entire algorithm is going to be structured. Yep. So what we have over here is we have this grid containing 9 characters. So this is a 3 by 3 grid. And the word that we are given over here is SEE. And we want to find whether this word exists in the grid or not. So I have a couple of variables over here. The current holds the current string that we are forming, and you will soon figure out like how the current works. But it is essentially when we find a character that we are looking for in a grid, we append it to the current. The P is the current index or the current number at which where we are in our word search. So right now we are at 0, and since we are at 0, that's why we are looking for word at 0th index, and that is word of P is S. So we are looking for the first character S. So we start exploring the grid from left to right and top to bottom. So we go from A. So A is not the word that we are looking for. It's S. So we move forward. B is not the one that we're looking for. So we come to we move forward and we come over here. That's called S. And now S is something that we are looking for right now. So what do we do? In that case, our current becomes S because it will be assigned. This is something that we're looking for. We increment P by 1. And now the next word that we're looking for is E. Now here's the thing. Anytime we find a word that we're looking for, we are going to search, well, in all 4 directions for the next word. So how will that work? So we cannot go on top or right because that's the end of the grid, but we can still go on the left. We can still go down. And when we go left or right, we don't see the next word that we're looking for. So we don't find E. And that's why our recursive function, and this is a recursive function, so it will return back, and be we would be back at where we started. So we were over here. Now we would again continue our search, and the next we will be visiting this S. So when we visit that as, oh, so that was something that we were looking for. Now what do? When we find a word, we append it to the current, we again increment P, and we change whatever the next word we're looking for. And what do we do when we find a word? We deploy PFS, so we need to look in all 4 directions. We search for in the top direction. A is not something that we're looking for. When we go to the right, okay, perfect. So we see that it's E, and E is the word that we're looking for. So we are going to jump on the right. We're going to increment P by 1, and we are going to append the character that we found to the current string. So next time the current will become SE, P is equal to 2, and the new word that we are, new character that we're looking for is E. Now, if you have not already noticed, then I am, every time I find a character, I am replacing it. So I'm replacing that character in the grid with a dummy variable. And this is so that we don't reuse the same character again in our search. So for example, from over here, when we start our BFS, so we are going to go to top. B is not something that we need, not D and E. So we will reach at this location, and so in our case at least, let's say, so in our case at least, when we find, so we increment P by 1 or P by 1, so that becomes 3. Also this form, this is the word that we're looking for, so the word and current matches, so we will return it true. This brings me to 2 points. The first one, the P value is 3, which is equal to, which is equal to the length of the word. And this means that when we do this kind of lookup, it is going to go out of bounds. So had the current not been equal to the word and P would have been incremented to the length of the word, then we should return false at the time. But in this case, the current and word are equal, so we'll return true. Also, the other point about this pound signs, what this helps us is we will not consider the same word again had if we do BFS on. So had we still need had we still be needing to do BFS from this location, then when we look at the top direction, certainly no English word will have a hash sign in it or a pound sign in it, so we will not meet our condition of the lookup, and that's why that's why we will not consider the same word twice. um, I hope that made sense. If you have any other questions, then do comment in the video below. Let us walk through the code and see how that would work. So let us minimize that and go over here. So the first thing that we were doing in our algorithm was we were going to loop on our grid from left to right and top to bottom. So that's what we are doing. Now what we do is we are already given a word. So initially, in at least in our function, what we do is if we find a character which is equivalent to the zeroth index of the word, then we deploy PFS. So for our example, and let us just walk through this board. And if we are looking for A, then, and this is just not, this is just temporary variable that I've created. Anyways, so if we find, oh, so the first character is A. So what we'll do, we will pass the current board that we have received as the input to the BFS function. We'll pass the index at which we found the current character. So INJ, we need to increment. So initially the P was in initially it was 0, the P value is 0, and now we are sending 1. So in this way, this is like a fancy way of incrementing it, to be honest, because it's whenever we are in this outermost loops, where the P is always 0. So by doing this, I'm just saying that, hey, now pass the value of 1 to P. And what we do is we pass the initially, so initially we are always passing the current, whatever is the first character in our word. So that's that. Now, of course, like the current word, so the current string is not going to be equal to the word, because we are not looking for A, we are looking for A, B, C, C, E, D. So this is not going to hold true, so it will still continue forward. P is not greater than or equal to length of word, and current is not equal to word, so we will still go forward. But we will reach here. So what we do is we are going to explore all the possibilities that are there. So I plus 1 j, and this is just a standard BFS approach in any grid based problem. So we are going to go in all 4 directions. Now we need to have some validations. that we don't go out of bounds. So we don't want to explore stuff which are outside the grid, so not outside, like outside this grid, so less than zero. So if something is less than zero or greater than the length of the board, so we don't want to go there. Now let us say that this x and y, if we find the next word that we are looking for, so since this has been incremented already, so the next character that we're looking for is b. So let's say we find it. So what do we do in that case? We create a temporary variable to hold the current word that we have. So we have this a, we replace that character, so in the grid, with the pound sign, and then we pass the board to the next recursive call. Now, how do we do? What else do we do? We, of course, wherever we found the new character that is forming our string, so we are going to pass those x and y coordinates. We are going to increment the p value, and we are going to append the current string with the next word, next character that we found. So now it would become a and b. Um, so at this line of code, and line 16, we are again come back on the top. And this function is gonna recursively call itself until it meets either this criteria, return false, or it just explores the entire grid and there's nothing. So at the end of this for loop, we have nothing. So essentially what it means is it will return none, which in Python means return false. So however, in our case, like it will start exploring A, B, C, C, E, and D, and at the end it will return true. Uh, so what would be the runtime complexity of this algorithm? First of all, we are going to loop m cross n, so that is always there. And we are also gonna loop for the number of elements that we find in a word. So it is the length of the word. So the runtime complexity would be n cross m, where n and m are the length of rows and columns, and multiplied by the length of the word, where so it will be length of w, or length of the word, my bad. The space-time complexity, it should be O of n, where n is the length of the word, because we are still concatenating each and every character. So we are still forming a string, which is at the end being used in this comparison. So that will still be stored in a stack. So that we are going to use. So it's O of the length of the string. Um, so that's the end of the tutorial. Do let me know if you found this useful. The next I'm going to solve word search 2, which is one of the most asked questions in Google interview. If there are other questions that you would like me to solve, do let me know. And if you found this video useful and would like to be notified, then hit the bell icon below. Please subscribe, like, comment. Until then, have a good day. Bye bye.